Write a triangle part 4 for grade 8 English. We have two objectives. In this lesson we will recognize the properties of a semi-equilateral triangle and we will solve real-life problems using Pythagoras Theorem. Objective 1. Properties of a semi-equilateral triangle. Recall, a semi-equilateral triangle is a right triangle where the adjacent angles of its hypotenuse are of measures 30 degrees and 60 degrees. ABC is a semi-equilateral triangle at A with CBA is equal 30 degrees. M is the midpoint of BC. So here we have ABC is a semi-equilateral triangle, angle B is equal to 30, angle A is equal to 90, then of course angle C is equal to 60 degrees. We have also M is the midpoint of BC. Find AC as function of BC. We have to find the length of AC as function of BC. What do we mean by as function of BC? That is, we have to find AC with respect to BC. For example, AC might be third BC, might be 3/4 BC, might be half BC. So as function of BC. Find AC as function of BC, we have to follow the following steps. The first step is to show that AM is equal to MC. How to show that AM is equal to MC? We have AM is the median relative to the hypotenuse BC, since M is the midpoint of BC. AM is equal to half BC, since ABC is a right triangle and AM is the median relative to the hypotenuse. So, AM is equal to the hypotenuse over 2, which is BC over 2. Also, we have MC is equal to BC over 2, since M is the midpoint of BC. MC is equal to BC over 2 and AM is equal to BC over 2, then by substitution we get that AM is equal to BC. The second step, show that MAC is an equilateral triangle. We have here to show that MCA is an equilateral triangle. MA is equal to MC just proved. So MAC is an isosceles triangle. MAC is an isosceles triangle, so we need a 60-degree angle to have an equilateral triangle. Since if it is an isosceles triangle and one angle is 60 degrees, then the other two angles must be 60 degrees. Since ACN is equal to 60 degrees, in a semi-equilateral triangle, we have angle 90, angle 30 and angle 60. So C is equal to 60 degrees. Then AMC is an equilateral triangle by isosceles with one angle 60 degrees. Last step, we have to deduce that AC is equal to BC over 2. So, as we see here, we have to prove that AC is equal to BC over 2, which is AC as function of BC. How to prove it? AC is equal to MC. AC is equal to MC since MAC is an equilateral triangle just proved. MC is equal to BC over 2 since M is the midpoint of BC. Hence, by substitution, we get that AC is equal to BC over 2. AC equal to MC, MC is equal to BC over 2, then AC is equal to BC over 2. What do you conclude? The conclusion is, in any semi-equilateral triangle, the side opposite to angle 30 degrees is equal to half the hypotenuse. So here we have a semi-equilateral triangle. In any semi-equilateral triangle, the side opposite to the angle 30, which is AC here, is equal to half the hypotenuse, and that's what we just proved. Example, we have EFG is a semi-equilateral triangle. EF is equal to 6 cm. What is EF? EF is the hypotenuse. We have to find the length of EG. Since EF is the hypotenuse, E is the angle 60 degrees, F is the angle 30 degrees, then EG is the side facing angle 30 degrees. So EG is equal to half EF, which is 6/2, 3 centimeters. Methods to show that a triangle is a right triangle. The first one, if the sum of two of its angles is 90 degrees. Of course, if the sum of two of its angles is 90 degrees, then the third angle will be 90 degrees. If the median relative to one side is equal to half that side. This is the first rule in this chapter. If one side is the diameter of a circle while the opposite vertex is on the circle. If we have a triangle and one of its sides is a diameter of the circumscribed circle above this triangle, where the vertex opposite to this diameter is on the circle, then the triangle is a right triangle. If the square of one side is equal to the sum of the squares of the other two sides. This is Pythagoras Theorem. If Pythagoras Theorem is applied and verified, then the triangle is said to be a right triangle. The last method, if one of its vertices is its orthocenter. The orthocenter, as we know, is the point of intersection of the heights. If the point of intersection of the heights is one of the vertices of the triangle, then this triangle is a right triangle. Objective 3. Solve real-life problems using Pythagoras Theorem. Problem 1. Fadi's house is on fire and he is stuck in it. The fireman extends the ladder to rescue Fadi. Find the length of the ladder so that the fireman can reach Fadi. As we see here in the picture, the distance from the ground to Fadi is 40 feet. The distance from the house to the fireman is 60 feet. Feet is a unit of length. The fireman wants to extend the ladder to reach Fadi. We want to find the length of the ladder so that the fireman can reach Fadi. We notice that the ladder is making a right triangle with the house and the ground, where the ladder is the hypotenuse. So, since we have a right triangle, we can apply Pythagoras theorem to find the length of the ladder. Let's name this triangle ABC. AC squared, which is the hypotenuse, the ladder, AC squared is equal to AB squared plus BC squared. So AC squared is equal to 5,200. To find AC, we must use the radical. Using a calculator, we get AC equal to radical 5,200, which is 72.11 feet to the nearest hundredth. So the fireman must extend the ladder about 72.11 feet to rescue Fadi. Problem 2. Problem 2. Sarah wants to visit Sajid. She can reach Sajid's house in two ways. The first path is by walking along Street B and then Street A. The second path is by crossing Street C. So here is Sarah's house and here is Sajid's house. We have two paths. The first one is by crossing Street B then Street A to reach Sajid's house, or by crossing Street C. Which path is the shortest? Solution. The shortest path is by crossing Street C. It's clear that crossing Street C is the shortest path. Number 2. Since the path is making a right triangle shape, then we can use Pythagoras theorem. Let's name this triangle ABC. The shortest path is AB, which is the hypotenuse of this right triangle. AB squared is equal to AC squared plus BC squared. AB squared is equal to 1.5 squared plus 2 squared, since the first path AC, which is Street B, is 1.5 miles, and the second path, which is BC, Street A, is 2 miles. So AB squared is equal to 6.25. To find AB, using a calculator, we find the radical of AB, which is radical 6.25, which is 2.5 miles. So the shortest path from Sarah's house to Sajid's house is path AB, street C, which is 2.5 miles.